Chapter 4 focuses on quadratic functions. Now, quadratics are equations that have a degree of 2. As a reminder, when we're talking about the degree of an equation, we're talking about an exponent. So in other words, these functions are all going to have a variable with a 2 as an exponent. So in other words, an x squared. In this section, we're going to be graphing these functions. So hopefully we remember that these make a parabola, a U-shaped graph. And in this section, we're focused specifically on graphing them when they're in standard form. Standard form is y equals ax squared plus bx plus c. Here in this graph, we're showing the parent function for all parabolas. All parabolas have a vertex. It's either the maximum or minimum. In this case, it's the minimum because it's at the bottom of the parabola. This vertex is at the origin 0, 0. All parabolas also have something called an axis of symmetry. It's splitting the parabola right in half. It's symmetrical around that line, and this axis of symmetry is at x equals 0. This is a vertical line, so it has the equation x equals some number, and in this case, it's right on the y-axis there, which makes it the equation x equals 0. All parabolas also follow the same pattern, which can change slightly, but the base pattern is up 1, up 3, up 5, up 7. If we look at this parabola here, we see if we take the first right, we're going up 1. If we take another step over, this time we go up 3. Another step over, this time we go up 5. All right, if we took another step over, okay, we would go up 7. Okay, then up 9, all right, up 11, etc. The equation for the axis of symmetry is x equals negative b over 2a, and the b and the 2a come right from the equation which was on the previous slide, standard form. This is going to simplify down to a single number, okay, and we're going to take that number and plug it in to find the vertex. So that's going to give us an x value. We plug that in to the equation up here, into all those x's, and that gives us our y value to find the vertex. The vertex is always right on the axis of symmetry, so plugging in that x value gives us the y value. Now that we've gone over all that, let's go ahead and do an example. Our equation is y equals x squared minus 4x plus 3. First thing to note, we have an invisible 1 in front of this x squared here, even though it's not shown. All right, now we want to go ahead and find that axis of symmetry and use that to find the vertex. So axis of symmetry, negative b over 2a. It's the opposite of b, so negative negative 4 over 2 times the a, 2 times 1. Okay, that gives us 4 over 2, simplifies to 2. Okay, remember this is the equation x equals 2. Okay, so our axis of symmetry is this line here. All right, now we can plug in 2 to find the vertex. So we take 2, we plug it into all of these x's up here, okay, and we see what we get for the y value. So 2 squared minus 4 times 2 plus 3, okay, and we get negative 1. So our vertex is 2, negative 1. Okay, we want to go ahead and put that on the graph here. Now this should always be right on that axis of symmetry. All right, and now that we have this, we want to go ahead and use our pattern to fill out the rest of this parabola. So we have our vertex at 2, negative 1. I'm going to change my color here. Okay, and then the first step as we move over 1, we're going to go up 1 spot. Okay, if we go over 1 more step, this next time we go up 3. Okay, if we go over another step, this time we're going to go up 5. 1, 2, 3, 4, 5 would put me here. Okay, and I'm just mirroring it on both sides of that axis of symmetry. So you can see the parabola take shape there, and then we're just going to draw it out. Okay, some questions that might ask, is this does this function have a maximum or minimum? This is a face-up parabola. That means that the vertex is a minimum. Okay, it's a minimum because it's at the bottom of the parabola. What is the function's minimum value? So at the vertex, the minimum value is just that negative 1. Okay, we really can answer those, or at least this first question right off the bat. Okay, we can tell if it's a maximum or minimum based on this leading coefficient. If it's positive, that's going to be a face-up parabola. That makes the vertex a minimum. If it's negative, it flips it upside down. Okay, we have an upside down parabola, which makes the vertex a maximum because now it's at the top. Example number 2. Problems like this tend to throw some of you guys off. When you look at this equation, you see there's only two numbers here. We have y equals x squared minus 5. The things that's missing is that there's no x in the middle. So we have the a, which is a 1. Okay. We have the c, which is at the end. Okay, but there's no b in the middle. There's really 0x in between those. So when we find the axis of symmetry, there's a 0 for the b. So opposite of b, negative 0 over 2 times 1, okay, gives us a 0 for that x. Okay, so our axis of symmetry is right on the y-axis, x equals 0. All right, plug in that 0. It goes in for all the x's. In this case, there's just 1. Okay, we get negative 5, so our vertex is at 0, negative 5. Okay, put that on the graph down here. All right, and then go ahead and use the pattern to plot the rest of the graph out. So we're going to go up 1, up 3, up 5, 2, 4, 5, puts us here. Okay, can we do another one? 3, 6, we'd be right off the graph, so we'd be like about up there if we went up 7. Okay, draw the parabola out. Okay, again, we have a minimum since that's at the bottom of the parabola. Okay, and the minimum value is negative 5. This problem doesn't have anything new in it, so if you want to pause the video and try this one on your own, go ahead and do it now. Axis of symmetry, x equals the opposite of b over 2a. So we have negative 8 over 2 times 2, and we get 2 for our axis of symmetry. Now when we write this out, just make note that it's really x equals 2. It's the equation of the vertical line. Okay, that's the axis of symmetry. So we really should be writing it like that and not just the number 2. Okay, we can draw that on the graph. All right, now we would plug in 2 to find the vertex. And when we plug that in, we get negative 2. So our vertex is at 2, negative 2. Okay, and that is down here. Now, normally the pattern from that vertex is to go up 3, up 5, up 7. But in this problem, we have a coefficient. We're going to do the pattern 2 times. Okay, so our first step, we're going to go up 2. Always moving from the previous point. So from the vertex, we move up 2. We're at those 2 points there. Next step, doing the pattern twice. This time we go up 6. So from that point that we were just at, now we move up 6. Now we are here. Okay, next step, if we did another one, we would go up 10, then up 14, then up 18, etc. Okay, this parabola has a minimum, and the minimum value is negative 2. Now for this last problem, you won't see a lot of problems like this, but you will see them occasionally. So here we have a coefficient in front of this x squared, and it's a fraction. Okay, now it kind of messes up the pattern that we work with. It does still work. You could go up 1, up 3, up 5. You're just doing it half a time. So you go up 1/2, and then up 1.5, which is half of 3, and then up 2.5, which is half of 5. And in this case, actually, we're going down because that's a negative. But it can be a pain. So once we have fractions as that leading coefficient, it's easier just to plug in numbers. Now, we can always plug in numbers. That doesn't go just for parabolas. It goes with any equation at all. All right, so just like the last ones, we find the axis of symmetry. We find the vertex. We get 0, 3 for our vertex. Oops. All right, so we are here. Okay, now instead of using the pattern, I'm just going to plug in a number. And I want to plug in a number that's easy to find based on this equation. All right, so considering this equation has a 1/2 here, okay, I want to plug in a number that's going to be easy to multiply by negative 1/2 once it's squared. So something like a 2, okay, because if I did 2 squared, I'm going to get 4. Okay, negative 1/2 times 4 is negative 2, plus 3 would be 1. Okay, so if I plug in a 2, I end up with 1 as my output. Okay, just mirror it on the other side of my axis of symmetry, which is right on the y-axis. Okay, that's really enough to draw my graph. I could always plug in another one. Say I plugged in 4, I get 16. Okay, negative 1/2 times 16 is -8, plus 3 would be -5. So at 4, I get to -5. Put another one over there. Okay, and just do it by plugging in numbers rather than by the pattern. Okay, it has a maximum because it's upside down. The maximum is 3.